Hello, all of you folks there in ACS Grade 9 NGSS. Currently, we are doing physics, and this week we have our very important summative test. So I decided to make this video after looking at everybody's formative work so that you could be ready for your summative at the end of this week. So let's go in and take a closer look.
So here we will see a reminder of the standard that we are focused on, which is to use mathematical representations to support the claim that total momentum of a system of objects is conserved when there's no net force on the system. So really what we are focusing on is known as an isolated system. It's important to understand how the system is made up, how the forces relate to each other, and of course use the law of conservation of momentum, the mathematical representation of this law. And to extend your proficiency, you should look here at what is required. Exceptional and consistent understanding. And to demonstrate your proficiency, which is where we want everyone to be as a minimum. If you can extend, that's great. Once you can demonstrate, that is really good. And student demonstrates a thorough and consistent understanding of the standard that we're looking at here. We are looking at science and engineering practices, cross-cutting concepts, and of course, specifically and important, these disciplinary core ideas. Explanations display an accurate understanding of the law of conservation of linear momentum, and that would be demonstrating, and explanations display a thorough understanding of the law of conservation of linear momentum. That is our main focus. Of course, we are also focused up here on calculations and systems diagrams here. So those are your three things: to explain, to calculate, and to diagram or to draw some kind of representation of the system. To help you, we have given you the equation here for momentum. P is equal to mass multiplied by velocity. We typically would be using mass in kilograms for our calculations and velocity in meters per second. So the unit of momentum is kilogram dot meters per second. How do you convert grams to kilograms? A reminder here. And here we have the equation for the conservation of momentum. This equation, of course, would have to be modified if you have two objects colliding and then they stick together. So here is our first question from our formative task. And here you see Mr. Warrenchuk throwing out the chicken drumstick from the window, and the question says, the drumstick had a mass of 200 grams and it was thrown out the window with a velocity of 3.5 meters per second. So what we need to do here is to convert 200 grams into kilograms. We do that by dividing 200 by 1,000. That's how you convert grams to kilograms. You divide by 1,000 and you get 0.2, and then you plug those two values into the equation here to calculate momentum. 0.2 kilograms multiplied by 3.5 meters per second, giving us a momentum of 0.7 kilograms meters per second. Then we went on to this question. If we watch a game of American football, we can witness many instances where momentum is being transferred. Suppose Gary had a mass of 90 kilograms and he's running down the field with a velocity of 2 meters per second. His opponent, Brock, has a mass of 120 kilograms and is stationary, which means that Brock is not moving. After the collision, Gary is stopped in his tracks. Means he's not moving anymore. What is Brock's velocity? Knowing that momentum is conserved, knowing that nothing external is going to interfere with this system. Just about plugging numbers here into the law of conservation of momentum. So one person was not moving stationary. That is Brock. So we could think of this individual here being Brock, and Gary running towards Brock at 2 meters per second. Gary a little bit lighter than Brock, 90 kilograms for Gary, 120 for Brock. That's before. So we plug all of that data into the law of conservation of momentum expression here. Then after the collision, Gary, he stops in his tracks, so 0 meters per second. But Brock is pushed forward a little bit, and he's got a mass of 120. Using this expression here, we just need to solve for v, which is the velocity at which Brock would be pushed forward. So, given the law of conservation of momentum, that the momentum of the objects before must be equal to the total momentum after, then we solve the left side of the equation and we get 180. 90 multiplied by 2, 180. 120 multiplied by 0 is 0. Adding them up, you get 180. On the right side here, we have a total here of 0. 90 multiplied by 0, but then 120 multiplied by the unknown velocity v, which we will call 120 v, or 120 multiplied by v. So what we need to do next is to just isolate v, or make it the subject of the formula. And to do that, when a multiplication is happening between these two terms, we need to do the opposite of multiplication, which is to divide. And whatever we do on one side of this expression, we need to do it on the other side as well. So therefore, we will divide 120v by 120, and we'll divide 180 by 120, and we'll make v equal to 180 divided by 120, and that comes to 1.5 meters per second. In terms of defining the system, it's about what I explained here with this picture and putting it into some diagrams with arrows and masses to help you visualize or understand how the collision is happening. In this question here, we will have a diagram to better define the system. And here we have a 1,250 kilogram box truck moving at 10 meters per second, and it hits a 1,200 kilogram Volkswagen Beetle moving at minus 15 meters per second. If the truck bounces back, what is the velocity of the Beetle after the collision? So one of them moving in this direction, the other one moving in this direction. Both moving in opposite directions, so therefore we have a positive value for the velocity of the truck moving from left to right of our screen, and a negative value for the velocity of the Volkswagen Beetle moving from right to left of our screen here. Remember that velocity, it's a vector quantity. It has a magnitude, it has a number, but we also need to consider its direction. So therefore, the truck is moving this way, we give that a positive, and something that is moving at 15 meters per second but in the opposite direction must be given a value with a negative sign in front of it. Now, with this diagram, we are ready to go to solve the problem. We can plug all of our information about before the collision right in here. We'll get 1250 multiplied by 10 plus 1200 multiplied by minus 15, and it comes up to these two numbers here, and we can add those numbers up. A positive plus a negative basically comes to this minus this, and you can plug that into your calculator. 12,500 minus 18,000, it will come to minus 5500. Then of course, what are we solving for? We are solving for the velocity of the Beetle after the collision. So going back here now to our law of conservation of momentum, and momentum before must be equal to momentum after. It's conservation of momentum. So the truck, we have data for the truck. It's 1250 multiplied by minus 10.5. think of the truck as going this way and then bumping off and going that way. So that's why the sign changes to a negative sign. The car, on the other hand, what's the car going to do is it's going to bump back this way. So already conceptually in your mind, in your thinking, you are thinking that V for the car would have to have a value that is positive. Now, once you get to this stage, you've done really good. You've laid everything out. Now it's just about doing some algebra, making V the subject of the formula. To do that, we need to get everything out of this side of the equation. And first up, let's undo this minus 13125. The opposite of that is to add that to both sides of the equation. So adding that number here to both sides, this comes 7625. And here, it just cancels this out. Then we need to get rid of the 1200, which is in front of a multiplication sign. So here, we need to divide again, dividing both sides by 1200. And then we'll get this is equal to V. And then we can rearrange and put V on this side and solve this. And we'll get the velocity of the beetle as it bounces back to be 6.35 meters per second. Now, for our final question. Bob is in a rowboat that is drifting with a velocity of minus 0.50 meters per second. He's lost his paddles and needs to make it to shore. Using his knowledge of physics, he knows that if he throws the heavy anchor, he will speed up. The anchor is 5 kg, and the mass of Bob and the rowboat is 150 kg. He's capable of throwing the anchor at a velocity of positive 10 meters per second. So, from our understanding of these signs, it seems that the boat is drifting one way and Bob is going to throw the anchor in the opposite direction. It is his intention to move in the direction of where the boat is drifting. But we need to sketch all of this in a diagram to better understand the system, the masses, and the forces involved. So here we have a little picture of Bob throwing his anchor off the boat. And think about it. If you throw this anchor off the boat this way, the boat is likely to go the other direction. So diagramming all of that into a systems diagram, as it's called. We have the boat, we have the anchor, we have Bob on the boat, and before doing anything, Bob and the boat had a mass of 150. The anchor was 5. Combine those two together. Everything on the boat had a mass of 155, and it was drifting in a certain direction at minus 0.5 meters per second. Then, what Bob does is he throws the anchor off the boat, and he wants the boat to go opposite to where he threw the anchor off. So, momentum before is equal to momentum after. 155 is the total mass of Bob, the boat, and the anchor. It's drifting at minus 0.5. So, working that out, you get negative 77.5. Then, Bob throws the anchor out. The anchor has a mass of 5 kilograms, and he throws it out at 10 meters per second. The boat remains with a mass of 150. We want to find the velocity at which the boat gets pushed in the opposite direction. Just doing the math, we will see minus 77.5 is equal to 50. The mass of the anchor multiplied by the velocity at which Bob threw the anchor, that's 50. 150, which is the mass of Bob and the boat, 150, multiplied by the velocity at which the boat is going to drift. So again, we need to make V the subject of the formula. We need to get rid of 50 from this side. It's a plus sign here, so we put a minus 50 from both sides. It's going to make the left side 127.5. And it's going to leave us with 150 V on this side. So we then need to get rid of the 150, which is multiplied by V. So when we want to get rid of that, this time we've got to divide. So we minus here because the 50 is in front of a plus sign. And we divide here because the 150 is in front of a multiplication, which is actually understood here. 150 multiplied by V. So we divide both sides by 150. Here, dividing this side, and here dividing this side. Then rearranging everything, we say V is equal to minus 127.5 divided by 150, which comes to a final answer of minus 0.85 meters per second. We need to remember, of course, that the systems diagrams, they only apply when we consider our system as being isolated, which means it's not getting any matter or energy interfering with it from the outside. There's no friction, there's no wind blowing. Here is another worked example that I have for you. Here, in this case, to distinguish between velocity before and after, this equation has used u for velocity before and v for velocity after. That doesn't matter too much, but you can follow the steps and see a simple example of how to make v the subject of the formula, and to end up here with an answer of 0.5 meters per second. And here are some very important tips for you. And finally, I want you to try these 4 questions now on your own in class, so that you can be ready for your summative test. And it's important that you do these by yourself, and then you check with me and make sure that your calculations are correct, your units are correct, and your systems diagrams are also correct. For each question, I would like you to draw a systems diagram to better understand the system. And of course, if you have any questions, you can still drop by during office hours this week,